Hi, these are the last section of notes for chapter 3, and we're going to be talking about area problems and how to maximize the area. So, before we begin, let's do a quick review. Area of a rectangle is, hopefully from geometry, you remember, let's do area of a rectangle equals length times width. You can also say base times height, right, like whatever it is. Area of a triangle is 1/2 base times height. Please remember that base times height is like a 90-degree angle, right? So it has to be like base, height, and then 1/2. Area of a trapezoid is, let's see, do you remember this one? Base 1 plus base 2 times height divided by 2. Or you could think of it as 1/2 base times height. Right, so very similar to like the area of a rectangle because it's sort of the same. Actually, more similar to this, but there are two bases. Okay, so let's talk about it. If the area of a rectangle is 50 and the length is 5 more than the width, what is the length and width? So the first thing you should do is identify what your original formula is for area. So we're going to use area of a rectangle length times width, and then you're going to plug in what you know, right? So we know that the area is 50. It's going to be 50 equals, the length is 5 more than the width. So let's call it 5 more than the width. Well, let's see, do I want to define it? Yeah, let's use x's only. So I'm going to say x equals the width. Right? Because if it's 5 more, then I need to do x plus 5 times x. Once you have this, then you can simplify, and you get 50 equals x squared plus 5x. And at this point, really what we need to find is what is the length and width, right? So if we can solve for x, then we can also solve for the length. So let's do 0 equals x squared plus 5x minus 50. And then anytime you have a quadratic, there's a variety of methods you can use, but the one you should always check first is factoring. And so we have two numbers that multiply to negative 50 and add to 5 are positive 10, negative 5, which gives us our answer of x equals negative 10 and x equals 5. Well, width can't be negative, right? So we know that this negative 10 is out. So I'm going to say width cannot be negative. And so our width is 5. Let's try to complete the sentence. The width of the rectangle is 5, and it doesn't say units, right? So it's 5, let's say units, and the length of a length is, let's see, so now we have to plug it back in, right? So we take x, length equals x plus 5. So we're going to say it equals to 5 plus 5, which is 10. Okay, and so that sentence is your final answer. So now let's continue and keep going, right? So I think this is exactly the same. If you wanted to pause the video here and try it yourself, please feel free to do so. This is a great you try moment, and then you can just fast forward to the end and check your answer. If you're feeling a little shaky, you can try it with me. I do suggest you try it on your own though. Passive note-taking is never as effective as active note-taking. Okay. So my area is 45. 1/2 is in the formula. The base is 2x plus 2. And the height is x minus 3. Well, it's exactly the same, right? So at this point, you're going to distribute and solve the quadratic. Let's see. I can take half of this first part very easily. So let me do that. Please do not distribute to the second parentheses, right? So it's like this right here is what we're multiplying. It's like if I said like 5 times 2 times 2, you wouldn't say 5 times 2 and 5 times 2, right? You would just do 5 times 2 and then the third number. So this will be 1x plus 1, and then x minus 3, x squared minus 3x plus 1, x minus 3. We'll set it equal to 0 and combine like terms all in one go. Okay, factor that, two numbers that multiply to negative 48 and add to negative 2. That'll be negative 8 and positive 6, sorry. So once again, no negative numbers. You can't just say the base is 8, right? So the base equals to 2x plus 2. So let's plug it in. Notice that even though I can do a lot of this in my head, I'm still showing my work, right? Because just because you do it in your head doesn't mean I know what you're doing. So height. Oh, I'm doing way too much work. Look, it says, what is the value of x? Well, there's our value of x. The value of x. Let's do a word problem, word answers. Okay, so here's the danger of like, you know, not reading the question. Uh-oh, am I running out of ink here? If I wanted to though, right, the height is x minus 3, so it'll be 8 minus 3, which is 5. Okay, that pen is getting a little light. Let me change pens. Okay, so the area of a trapezoid is 36 units, the longer base, and so like guys, it's exactly the same. I actually want you to pause the video here and try this yourself, okay? I'm gonna pause and start working. You pause and do your own work. Okay, so I just wanted to set up my variables real quick. My shorter base, I'll make x. My longer base is 2 more than the shorter base. And the height is 3 times greater, right? So that's 3 times x. And once we have this, we can simplify. Let's see, how would I do this? Probably go 2x plus 2 times 3x. 1/2 distributes into the first parentheses. And I'm actually going to subtract 36 at the same time to save some time. And this will be 3x squared plus 3x minus, oh, sorry, that should be an x, minus 36. That's all divisible by 3. So I'm going to say that this is x squared plus x minus 12. And that'll be x plus 4, x minus 3, so x equals negative 4 or positive 3. And it's asking for, let's go back and not make that same mistake, what's the height of the trapezoid? Oh, I can just write it underneath because the height is 3 times x right here. And so I'll replace x with 3, which gives me 9 units. So the height of the trapezoid is 9 units. let's move on to maximizing area problems. Earlier in our warm-up, we talked about how like maximizing the area is really the vertex of a parabola, if you think about it. Okay, so well, let's set this up first and then we'll talk. Ready? So you need to maximize the area of a corral for your pet goat. There's a barn on one side of the corral. Okay, guys, word problems, draw a picture. This will help you understand what you're really doing. Okay, so let's see. We'll put the barn here. And it doesn't matter which way you draw this. This is just me. Okay. And then there's 3 sides. It says there's 1,200 yards of fencing available, but other than that, you don't know very much. Okay, so let me just make this a little bigger. Okay. And our goat is going to go in here. Now, we know we have 1,200 total, right? We know the area, here, rectangle. We know the area of a rectangle is length times width. And we now know that we need to set up or define our variables. Okay, so let's say that these 2 sides, assuming that they're different, we'll have x be the shorter side. Okay, so let's label those there. Now, that means that the longer side must equal to 1,200 total minus x minus x. Does that make sense? Right, because we're taking, like, we know we have the whole thing, and our fence, I should highlight this. I see why I did this in red last time. Our fence is this dark part only. Right? So it's going to be 1,200 total, and I have to take away these 2 pieces to get what's remaining. So this will be 1,200 minus 2x. And so once we have this, we can find the dimensions of the rectangle, right? Now we just need to find dimensions, means length times width. Length and width. So let's do it. We have area is, we don't know. Sorry, guys. Area equals x times 1,200 minus 2x, right? And so that means we have 1,200x minus 2x squared. I'm going to rewrite that in standard form. Minus 2x squared plus 1,200. And we don't know the area this time, right? So area is an unknown. We're not trying to find the area per se. We could if we wanted to. But we have this quadratic function now. And so if you were to imagine this quadratic function, let's see. We know that this is a function that's shifted 1,200 up, right? And it's going to be going down. So far, so good. And so if we know that, like, we want to somehow find the area in here, right? Which area will give you the most? We need to find the maximum height. Why is it not? Oh, I wrote this wrong. I'm so sorry. I was like, this should not be centered. Okay, so let me redraw this picture. Apologies. Okay. So we know nothing. We know that this is an x and y. And I personally know that it's going to be somewhere over here. You guys don't know that it's going to be somewhere over here yet, but this is going to be like our sketch. Okay, you could check with your graph. But we want to find the vertex because that's going to give us your maximum, like, what do we call x? X was our shorter side. You can call it width or length. It doesn't matter, right? Okay. And so that's going to be our biggest area, right? So if this is our area curve, we want to find the biggest area, which is our vertex. I hope that made sense. I'm sorry. So if we want to maximize area, equals find vertex of area function. Right? Because if this is an area function, then I need to find the biggest one. Pretty straightforward. So let's do it. It's standard form. So we're going to use x equals negative b over 2a. I'll have negative 1200 over 2 times negative 2, which is negative 1200 over negative 4, which is 300. Okay. And so hopefully you realize that now that is my shorter side, right? So the dimensions is one side, let's just call it the dimensions. The dimensions of the largest area, largest rectangle, fenced rectangle, is 300 by 300 what? 300 yards? Yes. By, and now we need to find the other one, which is pretty straightforward, because if this is x, then I know that other side equals to 1200 minus 2x. I'm not calling it length or width since those are interchangeable. Okay, so that's 1200 minus 600, which is 600. So it's 300 yards by 600 yards. And its largest fence rectangle using 1200 yards of fence, if you wanted to be super specific. Okay? Oh, sorry about that. My paper was totally moved. Okay, so let's do our last example. You have a 500-foot roll of fencing and a large field. You want to construct a rectangular playground area. So let's draw a rectangle playground. Okay. What are the dimensions of the largest such yard? Okay, so same ideas, right? So we're going to say like x and x. We'll call it the shorter side and the longer side just to define our variables. So let's have our shorter sides be x. Our longer side is going to be 500 total, right? Minus x, but that gives us 2 longer sides. So we need to divide by 2. Does that make sense? So I'm going to write in here, this is divided because we have 2 longer sides. And the difference here was that we didn't have a second longer side because the barn took care of it. Okay. So we need to do, let's simplify this because that's a hot mess. 500 minus 2x over 2, which is same as 250 minus 1x. Okay. And so if you combine like terms here, like these two x's would cancel, these two would cancel, and there's the 500. And so let's write our area. Length times width, x times 250 minus x. So that equals to 250x minus x squared minus, no, negative x squared. Sorry about that. Let's rewrite that. That's going to mess me up later. Negative x squared plus 250x. Okay, so we want to maximize area. Which is find the vertex. And once you find the vertex, you're going to use standard form again. Take a moment, see if you can do this yourself. Everything is pretty straightforward. I'll pause it. Okay, so after I've done this, I've solved for the vertex, which is 125 for one of the sides. I plugged it back in to find the other side, which is also 125. Hopefully that triggers, you should remember that a square is the largest area. You cannot just make that statement and prove it here, right? Because you saying that doesn't prove anything. So if you wanted to prove it to me somehow that a square is the largest area, great, on the test, then you can say that and then just know that it's 125 by 125. This proves that the square is the largest area. And then don't forget to answer the second question, what is the largest area, by multiplying 125 by 125 for a total of 15,625 feet squared. Okay. So tomorrow in class we'll practice more of these maximizing area questions, and we'll move on to maximizing revenue as well.